In this video, we are going to solve something that's going to turn into a rational equation. So that's going to be something that turns into an equation that has a variable in the denominator. So we did one example. Our second example on this is called moving sidewalks. So it says the moving sidewalk at O'Hare Airport in Chicago moves 1.8 feet per second. So it's just kind of the horizontal escalator kind of a thing. So moving walkway, 1.8 feet per second. Walking on the moving sidewalk, Rosalind travels 105 feet forward in the same time that it takes to travel 51 feet in the opposite direction. Because one you're kind of going with the current, and then the other one you'd be going against the current, so you go slower. So how fast does Rosalind walk on a non-moving sidewalk? All right, so I look at this as a rate times time equals distance kind of a thing. So rate times time equals distance. So I like to build a chart for this. And build a box. So I got a rate, I got a time, I got a distance. So with and against is what I'm looking at. So with the sidewalk, I have my rate, which I don't know, plus an additional 1.8 because the sidewalk is helping me, so it's increasing my speed by 1.8. I don't know how long it takes, but however long it takes, I will travel 105 feet. All right, and then my other one is my rate, and I'm going against the current, so I'm going against the sidewalk. In the same amount of time, it takes 51 feet. Okay, so the way I'm looking at this is these are a rate times time equals distance type of a problem. So we have rate times time equals distance. So rate times time equals distance. And then my second equation is another rate times time equals distance. So what we create out of this is a system of equations. So either I'm going to be doing elimination, which you can, or you're going to be doing substitution. The tricky part about elimination is when you distribute this in, you're going to have multiple variables on this. So you're going to have an RT and an RT, which is going to make it a little trickier. So substitution ends up being a little bit of a better approach. And so let me show you what we got. On this equation, what you can do is solve for time. So I'm going to divide this piece over. So let me shift this over to the other side. Let's go rate minus 1.8 times time equals distance. So I'm going to divide both sides by r plus 1.8. R plus 1.8. That way I get time equaling my distance divided by my rate. And then over here, I'll do the exact same thing, but it's r minus 1.8. And so then now my time is my distance divided by my rate. So that's very nice because now we've set both of these equations equal to t. So if t equals this and t equals this, then they have to equal each other. So that's how I can approach solving this problem, is by setting these two equations equal to each other because they both equal t. So they both have to equal each other. And then, I'm not sure where my 51 became a 50. Okay, now, so good news, it looks like it's an ugly problem, but we can cross multiply to solve this. So if we cross multiply this, we'd have 105. Let me start to do this over here. We have 105 times r minus 1.8 equaling the other cross product of 51 times r plus 1.8. All right, so we'll distribute. So 105 r minus 189 if you multiply those two, and then 51r minus 91.8. Okay, So now we'll put the r's together. So I'm going to move the 51r over to the other side. Minus 51r minus 51r. We'll add the 189. So the 51r went over to the other side. The 189 is going to come to this side. Plus 189. So 105 minus 51 is 54. Negative 91.8 plus 189 is, I don't know. Oh, I should have a positive here. So that was a positive, so that's actually adding them together. That makes more sense. 280.8. All right, and then we'll divide by our 54. And so then in the calculator, we get about 5.2, and it's a rate, so feet per second. And that is what they were asking for. They were asking for how fast does Rosalind walk on the non-moving sidewalk? She would be walking at a pace of 5.2 feet per second. If they needed the time, because sometimes they'll ask maybe both of those things, or they were not asking for the rate, they actually want to know how much time she spent walking, then I would just be taking this 5.2, and I could plug it into any of these, or I could probably be easier to plug it into one of these, where I would add the denominator together and take 105 minus whatever you get here, or you take 51 divided by whatever you get here when you take 5.2 minus 1.8. All right, so that was solving the second problem, and then we'll do one more.